All right, welcome back to another installment of Unit 6, Coordinate Geometry for Math 2. I just realized I did not put a joke of the day in there. Oh, great. I just saved you a minute of your life. Okay, so Lesson 8. What have we got? We've got a formula for the equation of a parabola. We've already seen that formula, but now we're kind of deriving that equation when we're given a focus point and given a directrix. So with a focus point, if you remember, right there, we called it those coordinates for the focus A and B. It makes it easier, and that was the way we used it in Desmos as well. And then for the directrix line, we're calling that coordinate C, wherever that y coordinate is. And that's how we worked and we got our formula we came up with in the last lesson. Y minus c squared equals x minus a squared plus y minus b squared. So we use A, B, and C, and then the x and y, any point on the parabola that fits those. Basically what that's saying is that the Pythagorean theorem is true if we think about the change in x and the change in y, and the change in those distances. It's just a little bit different than the distance formula itself. So here we go. Let's take a look at how it works in action. Ready? Camera, lights. Actually, I think it's lights, camera, action. I don't work in Hollywood. But here's what we got. If we took a look at the red side here, this is from the focus right here, focus point, to point A. We're going to check out how that looks with our formula. So we're saying, okay, that means y minus c. Well, here's our x and our y. Actually, in this case, our point on the curve is our x and our y right there. So we're going to say that that's y minus c. So 5 minus c. In this case, c is 0 down here. It's down here. If I highlight it, it's that directrix coordinate. What you're really checking right now, you're checking the distance from straight down that line. So from 5 to 0, oops, wrong color. It's 5, and you square that, and you get 25. All right, so that's kind of the idea there. That's that from 5 down to 0 is 25. And then over here on the other side, you've got this x minus a. We're going to use that. So we're going to say x minus a. X is 2. A over here is negative 2. So you got 2 minus negative 2, or 2 plus 2. I'm going to square that. So 4 squared, that's 16. All right, so that's what we're looking at right there, 16. And then over here for our y minus b, remember y is our coordinate on the point. And if you forgot where that is, I'm just making that point bigger right there. So that's going to be our y coordinate of 5 still. Take away b, which is 2. That's over here on the focus coordinate. So it's using those. We got to really get familiar with a, b, c, and how we're using those in our parabola formula. So 5 minus 2 is 3. 3 squared is 9. 16 plus 9 is 25. And what that basically says, in a nutshell, is that 25 is the distance squared vertically and on that angle. So those are equal. Yes, that point is on the parabola. We just proved it by proving equidistance. 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 I could say that 100 times, but that's what we're proving, is that those distances are equal. All right. So now, how do we build out the equation? Well, let's see. Kind of got one right here. We're just going to write this one out. We've got A and B there. We've got that focus point, if you will. And then over here, we've got our x's and y's. That's our coordinate. There's our directrix line. In this case, it's still the x-axis right now, so it's still y equals 0. So we still got c right there as 0. So we write this one as y minus, what do we say, c. So it's 0 squared equals x minus 3. That's our x-coordinate. And then y stays. So x and y, you notice, never become numbers. X and y are kind of always those any. This is our general equation. We come in here and we say, okay, well, y minus b, which is so minus 2 squared. And you know this y minus 0 squared, we usually just write that as y squared. So we're just kind of writing this thing as y squared equals x minus 3 squared plus y minus 2 squared. And that's our general equation. That looks, we can see from that, we can tell where the directrix is, the 0 right here, and we can tell the vertex coordinates h and k. So that's why we call this focus directrix form, is what we do. Focus directrix form. Because it shows us, in this form, it shows us the focus and the directrix. All right, now question 2 here says, it's not a very easy to read form, so what about vertex form? So let's pause the action for a moment. You can look down at vertex form. You see all of a sudden we got 2 new letters, H and K. So pause this at the moment. Take a deep breath. Grab a drink of water. Use the bathroom. Whatever you're going to do, I'm going to do the same thing. I'm going to pause my recording and come on back. Okay, I hope you took a good break for a moment. And if you didn't, pause the video again and take a break. But this is where things get a little interesting in the IM curriculum. Hey, let's just take it in that form and write it in vertex form. Let's just throw in an H and a K. Well, that's much easier said than done, I think, because we can find the vertex of the parabola. It's right here. I'm putting it in green. Right there, just in case you don't see it. It's right there. But that point 3, 1, how does that fit into our formula? It doesn't. We have to actually manipulate this. So what I'm going to do is I'm going to flip over. So I'm going to flip a few pages, and I want you to do the same thing. We're going to try a different problem real quick, and we'll come back to that one. All right? So here's the end in the summary. They actually show us how to do this, but they show us how in the summary. So let's take a look at this equation right here. This is in, remember, focus directrix form. Because I can tell from looking at it that the focus point was 0, because there's the y squared, there's no c value, it's y minus 0 squared. And I can also tell the focus point is 1, 4. How do we get there? Well, here's what we're going to do. In that vertex form, the x part of it stays the same. It doesn't change. So we're not going to do anything to the x part of it. So right now, if you follow along here, I'm going to start in purple here. I'm right here at step number 1. Nothing's really going to change with the x part of it. What we are going to do when we go down to step number 2 here is we're going to expand out the y's. And what we did here, I'll write it out. You took y minus 4 squared and you expanded it out so that it's y squared minus 8x plus 16. And if you're still not sure where that's coming from, go back to the lesson on squaring binomials, way back in lesson 6. So it's y squared up front. That's what comes up front. It's the 4 squared in the back. And in the middle, in the Chewy center, it's minus 4 times y. And I just put an x there, I realized. Got to use the right variables. Minus 4 times y and double it. So that's how you're getting that. So that's where they're getting that from. So you expand out the y's. That's our mission right there. So we expand out the y's. So I'm going to put notes right here. So expand the y expression. Or actually even better, you might know what is this. Expand out that y minus b piece. That square. All right? Then you'll notice what happened next here in step 3. If we take a look down the road, the y squared's disappeared. And that's not a problem because what happens is they subtracted y from both sides of the equation. So the y squareds do, in effect, cancel each other out. That's okay. So over here you got 0 on the right. And then now it's starting to look a little like vertex form, but not quite. So in step number 4, we added, actually what they did was they subtracted. They subtracted the 16. They subtracted the x minus 1 squared. So they moved all, I'm going to call this non-y terms, to the right. So basically they subtracted x minus 1 squared and they subtracted off the 16. So now that's where we're at step 4. And at that point, the last step was really to divide the whole equation. And I'm going to write this, I'm going to obliterate this. Divide the whole equation by 8s, negative. That way you end up with y equals. And when you do that, what they really mean by that is divide everything by 8. Divide that term by 8. Divide this term by 8 and divide this term by 8. Now, minus 8, hold on, I forgot the negative. There we go. Minus 8 divided by 8, that cancels. So you're left with y equals. And over here, this minus x minus 1 squared, that becomes minus, and dividing by 8 is the same as multiplying by 1/8. So they usually show it as a fraction here. So that's why you're saying 1/8 x minus 1 squared. And then over here, this minus 16 divided by minus 8, that's plus 2. So the two negatives cancel out. So now it's actually in vertex form. So that's actually where our h and k come from. They're right here. There's h, there's k. All right, so we've been working with a's, b's, and c's, and now we're kind of back in the sense where we know the vertex. This thing bottoms out. The vertex of this parabola is going to be at 1 and 8. And if you're wondering why I'm saying 1 and not negative 1, it's because it's x minus h. That's an ugly h. So that's our vertex form. Now let's go back to our previous example and see if we can follow that through. Okay, so I'm going to pause for a second here, and I'm going to go back to the other one. So let's go back to our problem here. We had in focused directrix form y squared equals x minus 3 squared. So let's start right here. Y squared equals x minus 3 squared plus something else squared. Let me go back to it. Y minus 2 squared. Okay, we're going to do the same process. So we're going to keep the y squared where it's at, over on the left. The x minus 3, don't touch the x term. That's already in vertex form. Notice the x coordinate a, that 3, is also the same as the x coordinate of the vertex. That's because it drops straight down to the directrix line. The x doesn't change. But we do need to expand out these y's. So we got y squared in the front, we got positive 4 in the back, and in the middle, minus 2 times y doubled. Minus 2y is minus 4y. All right, so there's our first step. Now, we want to make a note that y squared minus y squared cancels off, so we can just kind of eliminate that right away. And this kind of over here is 0. So now we want to move all the y's over. Last time we moved all the x's over to the right. It can be done either way, but really the easiest thing to do here is to think of this as adding 4y to both sides. That way we come on over here and we say, okay, great. We're set up with 4y equals x minus 3 squared plus 4. And now our last step is going to be pretty much our last step. Divide the whole equation by 4, or some people say multiply by 1/4. But we're going to say divide everything by 4 here. It's just a little easier to deal with. So divide by 4, 4 cancels. You're left with y equals. Divide this whole thing by 4. We said earlier that's the same as multiplying by 1/4. That's why we're kind of getting that 1/4 out there in front of the x minus 3 squared. And then 4 divided by 4 here is just 1. And so what we can see now is we can see our vertex. There it is, 3 and 1. And we can go back to our previous lesson and see it's right here again at 3, 1. That's pretty much that lesson. Now this takes practice. So you gotta do a few of these before you really get them down, but the process is the same. Let me go back to the summary now again and say this process. Pause on this, check it out, go back through the video, go through that process. I could be here for an hour, but at the moment it's 3:30 in the afternoon, it's beach time, and this video is now almost 15 minutes long. I couldn't do it really any quicker, so you can stop there. I'm going to pause, and I'm going to do 2 more little quick ones, and I'm going to show the results, because I want to keep this video short, and then we'll come back and let you guys take it off from there. I'm keeping this thing under 15 minutes. Okay, just real quick. There's that x-axis again, y equals 0. That's your c value, just so you know how to use that. This focus point, 4.1. So you're looking at same distance. You're just rewriting that equation with A, B, and C. So with that said, I'm going to pause one more time. And we're going to end it right there with the bottom line. I'm going to let you read this, but basically you got to practice and understand that parabola equations in both the focus directrix form and the vertex form. And to get from one to the other, you got to quickly expand out those squared binomials and solve. And this all incorporates that idea that equidistant from the focus to the point and from the point to the directrix. So we're taking the distance from it and adapting it to parabolas. Or you call them quadratics. All right, hope this is a long one. I try to keep it as short as possible, but this is a tough lesson. That's why we're going to be doing it towards the end of the week. So see you then, or already seen you. See you later.